Hello everyone, welcome to the course Structure Analysis. I am Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today we are at the 29th lecture. We were discussing about the two hinged arches. So far we have seen if the two hinged arches is subjected to UDL throughout the span or part of the span having the UDL, what is the horizontal thrust? We derived it. Now in today's lecture we are going to see if the two hinged arches is subjected to the eccentric point load, what would be the horizontal thrust and then maximum bending moment. So this is the third lecture on the two hinged arches and the lecture number is 29. So at the end of the lecture, student can able to analyze the two hinged arch subjected to an eccentric point load. So quickly we will discuss this problem. Like this only in the examination also the problem will be asked. For example, a two hinged parabolic arch has a span of 12 meter and a central rise of 6 meters. A concentrated load 20 kilonewton acts at 3 meter from the left support. The second moment of inertia varies as a secant of the inclination of the arch axis. Calculate the reactions and then horizontal thrust at the hinge. Also calculate the maximum bending moment. So he can able to see it here. This load is kept 3 meters from the left support. The hinge is provided at the support A and then support B. Since it is a two hinged arches, we don't have the arch at the crown of the arch. So only we have the hinges at the support A and then support B. Now we are going to calculate the reaction force for this. So I am taking moment at the point B. So taking moment at the point B, force multiplied by the horizontal distance. So this is the horizontal distance of 12 meters. The force is VA. So we got 12 times of VA. And then this load minus 20 is acting at the distance of 9 meters. How this 9 meters came? Total distance is 12 meters, 12 minus 3. So 12 minus 3 is 9 meters. So 20 into 9 equal to 0 because here the hinged support is there, the moment at the support B is 0. So we got VA is equal to 180 by 12, VA is equal to 15 kilonewton. We got the reaction of VA. Now what is the total load? The total load is 20 kilonewton minus of RA will be getting the RB value. Okay. So now we are going to calculate the horizontal thrust. We know what is the VA value and then we know what is the VB value. So VA is 15, VB is 5 kilonewton. Let's mark it here. VA is 15 and VB is 5 kilonewton. Okay, always don't forget to write the units. Now what we are going to do, we are going to calculate the horizontal thrust, capital H. For the horizontal thrust, the formula is integral m0 y dx divided by integral y square dx. So which was derived from the strain energy definitions we have seen in the first lecture. Now you can able to see this arch is subjected to point load 20 kilonewton 3 meters from the left support. So we need to take the two sections. Both the sections are located XX meters from the left support. I am considering one section that is X meters distance. Similarly, I am taking the second arch, second section that is also X meters from the right support. So X meters from the right support one section, X meters from the left supports one section. For the two section I have written the equation with the boundary condition, with the limits. So integral over m0 y dx is now splitted into for two section y1 and then y2, m01 and then m02. First we are covering 0 to 3 meters. Next we are covering the support support B. So this point is considered 0 now, 0 to 9 meters. Okay, 0 to 3 meters we are covering and then 0 to 9 meters. So 3 plus 9 totally 9 meters we are covering. We are calculating the moment. Now M01, how this 15x is come? Because 15 is a point load acting in upward direction multiplied by the linear distance x is 15x multiplied by y1. So y1 is calculated here. The y1 is calculated here. So this is the equation of parabola. Actually this is 4 and then height. H is 6 meters. H is 6 meters. So this is actually 4 multiplied by 6. It's not a 46. It's a 4 multiplied by 6 into x into 12 minus x. So 4 multiplied by h value is h is equal to 6 here in the given in the problem, that is substituted here, and then length of the total length of the span is 12 meters, total length of the arch that we are substituted, and simplifying upon this, for example 6 into 4 24, and then this 24 divided by 12 square. So 12 square we will be getting around 144. So by cancelling this we will be getting 1 by 6. Okay, so this 1 by 6 we are keeping outside. Then we are multiplying this x term inside. We will be getting 12x minus x square. So this is the y value. This y value is substituted here. The y value is substituted here. So m0 y1. Now we are going to integrate it. For example 0 to 3, and then 15x is a moment, and then this is the y1. This is the m0 and this is the y1. Okay. Now 1 by 6 is nothing but the 2.5. This is a numerical number I am taking out of the integration, and then this x is multiplied inside. So x multiplied by 12x minus x square is there. Let's multiply this x inside. So 12x square minus x cube. Okay, so this x is multiplied inside the term. Now I am going to integrate it. If you integrate the x square, we will be getting x cube by 3. If you integrate the x cube, you will be getting x power 4 by 4, and the limit is 0 to 3. Now what we are doing, I am applying the upper limit minus lower limit. The upper limit is 3. Wherever x is there, I am going to substitute the value of 3, and then calculating this value, I will be getting 219.375. There is no need to substitute the lower limit because the lower limit is 0. If you substitute it, it becomes 0. So upper limit only substituted. Similar way, I am going to calculate the next term, which is integral 0 to 9 m0 to y2 into dx. For calculating this, we need to multiply RB into the corresponding distance. So once go back to the diagram, let me draw the diagram here. So this is our arch, 2 hinged arch. Here our VB is acting, which is 5, and here our VA is acting, which is 15 kilonewton. Okay, now we are talking about the second section. So that is from the right support. So we will be getting 5 multiplied by x. So we got the 5x multiplied by this. We know this is nothing but the y value, simplified value of y. Now this 5 by 6, in numerator 5 and denominator 6 I am taking outside. So 5 by 6 integral over 0 to 9 x into this term is there. Now what I need to do, I need to multiply this x inside the bracket. If I do so, then it is become 12x square minus x cube into dx. Now what I have to do, I need to integrate it. If you integrate the x square, it become x cube by 3, and then if you integrate the x cube, it become x power 4 by 4. Now applying the upper limit, so wherever x is there, we are going to put the upper limit value 9, and then simplifying. Lower limit you no need to substitute. If you substitute also, it will become 0. So after that, we are calculating this value by using the calculator. Simplifying this value, we will be getting 1063.125. Now already we have calculated the first part numerical value also. We can able to see it here. So in the first part, we got the value of 219.375. The second part, we have the 1063.125. So our numerator is the comprises of these 2 points, integral over 0 to 3 m naught 1 y1 dx plus integral over 0 to 9 m naught 2 y dx. Now these two values only we are calculating. I am just simply adding these two values. I will be getting the overall numerator value. This is 1282.5. So we got the integral over m naught y dx value. Now what I have to do? So in the overall formula, y square dx is also there. I am going to calculate the y square dx value. So y square dx is equal to integral 0 to 12 because the overall span of the arch is 12 and then this is the value of y. And since it is a y square, we are putting the square term here and then we are going to square it. Okay. So 1 square is square and then 6 square will become 36. So this 1 by 36 I am taking outside the integral. Remaining term, if you square the 12 multiplied by 12 will become 144 and then x square, this x will become x square and then this x square will become x power 4. So here actually what we are doing, we are substituting the formula. So this is actually a minus b the whole square formula, which is a square plus b square minus 2ab. A square plus b square minus 2ab. So that's what we did it here. This is the a square and then this is the plus b square and then this is minus of 2ab. Okay, we substituted, we elaborated the equation and then now we need to integrate it. If you integrate the x square, then it will become x cube by 3. If you integrate the x cube, then it will become x power 4 by 4. And integrating x power 4 will become x power 5 by 5. So after integrating, what we have to do? We need to apply the upper limit. Upper limit is 12. So wherever the x is there, I am going to substitute the value of 12 and then simplify it. We will be getting the value of y square. Now we are going to substitute all the values in the horizontal thrust equation, which is capital H is equal to m naught y dx divided by y square dx. Now m naught y dx is 1282.5, which is a numerator value, and then denominator value we calculated just right now, which is 230.4. So the horizontal thrust is 5.57 kilonewton. Now let's calculate the y3 value, and this is the y3 value. So 1 by 6 of 12x and minus x square already we have. In this equation I am going to substitute this 3 meters because we know that the maximum bending moment will takes place under the load. Most of the time the maximum bending moment takes place at the under the load. So that's what we are substituting this value 3 in this x equation. So we got the y value is 4.5. In this equation we need to put x is equal to 3 so that we got the y value 4.5. Now I am going to calculate the maximum bending moment. We know the VA value is 15 and then 15 multiplied by this x distance is 3 meters. This x distance is 3 meters. So 15 multiplied by 3. Then this HA value just now we calculated, which is 5.57. So HA value 5.57. H value is 5.57. So this is not 15. This is 5.57. Okay. So what I am doing here, the vertical force is 15 and then the linear distance is 3 meter. So we got 15 into 3. And then the load acting downward direction, the load is acting downward direction. We are not going to consider that because the load is acting at exactly at the XX section. So when we are taking moment, that particular location we are not going to consider. Now you can able to see the HA. HA is acting like this and then the perpendicular distance to this is 4.5 meters. Now you see the 15 into 3 is rotating in a clockwise direction. That's why this is positive value. But this H value is 5.57 multiplied by 4.5 rotating in a anti-clockwise direction. That's why we have the negative sign for the minus of 5.57 into 4.5. So once again I will rewrite this here for clarity, that is 15 into 3, okay, minus 5.57 multiplied by 4.5. So the total value is 19.935 kilonewton meter. Okay, so from this lecture we learned how to calculate the horizontal thrust. Also we learned how to calculate the maximum bending moment of a truss of a two hinged arch subjected to a eccentric point load. Okay, so in next lecture we are going to discuss about the two hinged arches, same horizontal thrust how to calculate it for the two hinged arches. Then we'll be moving the fifth unit or the last topic, flexibility and then stiffness matrix. Thank you for watching this lecture. Thank you.